Hello class, welcome to part 2 of the 0028 final. The next question is going to be a word problem, and it's going to give you a polynomial, and it's asking how far something is falling at a certain time. Let's say we get negative 16x squared plus 164, and it wants to know where it's at x equals 1. So all we have to do is substitute a negative 1 in for x, and we're going to get negative 16 1 squared plus 164. 1 squared is just 1, so we have negative 16 plus 164, which is 148. Then we're going to give two binomials, x minus 8 plus 8 and x minus 7. So we just need to multiply these two, and we're going to use the FOIL. So x times x is x squared. X times negative 7 is minus 7x. 8 times x is plus 8x. 8 times negative 7 is minus 56. Combine like terms, and we're going to get x squared plus x minus 56. Then we're going to give a binomial, let's say x minus 12 squared. And we need to square this binomial. We can either do this as x minus 12 times x minus 12, or we can do the shortcut where we square the first term. So x squared, 2 times the first times the second, which will be minus 24x, and square the last, plus 144. Then we're going to be given two terms, 24x y to the 3 and 60 x squared y squared. Find the lowest common or greatest common factor. Do the greatest common factor so that we can next factor things. So the biggest number that will go into both 24 and 60 is 12, and the greatest one that will go into both of x's is just x, and for y it's y squared. Next we're going to be given something with 4 terms, x squared y plus 3y plus 4x squared plus 12. And we need to factor this. To do this, we need to do it by grouping. So we can factor y from the first two and get x squared plus 3. We can factor out a plus 4 from the second and get x squared plus 3. Now we can factor out the x squared plus 3's, and we're left with y plus 4. Next, we're going to be given a trinomial. Let's say x squared minus 2x minus 24. And we need to factor this. We see that we have two minuses. So that means we're going to have one minus, one plus. And the minus is going to be bigger because our b term is a minus. So we're going to put x minus, x plus. Our two factors of 24 that subtract to get to 2 are 6 and 4. Next, let's say we have 3x over 4x plus 28. And on this one we're asked what is the domain. The domain is what are all the values of x that will work. So what we're going to do is find the values that don't work by setting the denominator to 0. When we do that, we're going to get 4x is negative 28, or x equals negative 7. So our answer will be all real numbers except negative 7. Then have something like x minus 3 over x squared minus 4x plus 3. And we're asked to simplify this. So the top, the numerator is already simplified, but I'm going to put it in parentheses. For the bottom, we need to factor that. We're going to have an x minus and an x minus because of this plus. We need factors of 3 that add up to 4. So it's going to be 3 and 1. And we can see that we can cancel the x minus 3's. We're left with just 1 on top. So our answer will be 1 over x minus 1. You may have to put in the myopenmath the parentheses around the x minus 1 if you're not using the fraction tool. Now we have 5x to the 10, y to the 5 over 6x squared times y to the 3 over 8x to the 3, y to the 3. And we need to simplify this. What I'm going to do is multiply the numerators to each other and the denominators to each other, and then simplify. In this situation, that'll be a little bit easier. So 5x to the 10, y to the 8, and 48 x to the 5, y to the 3. We can't do anything with the 5 and the 48, so those are still going to be there. We have x to the 10 over x to the 5, which is x to the 10 minus 5, which is x to the 5, y to the 8 over y to the 3, so that will be y to the 5. Then we're going to have two fractions that we have to add. 1 over 10 plus 1 over 4. So we need to find the lowest common denominator, which is the lowest common multiple of the 10 and 4. That's going to be 20. So I'm going to multiply this one by 2 over 2, this one by 5 over 5. We're going to get 2 over 20 plus 5 over 20, which equals 7 over 20. Then I'm going to have something like 1 over x minus 3 minus 8 equals 9 over x minus 3. So the first thing I want to do is get rid of the denominators. So I'm going to multiply everything by x minus 3. When I do that, these x minus 3's cancel, these x minus 3's cancel. I'm left with 1 minus, and it's 8 times x minus 3, so I'm going to distribute the 8 and get 8x, and it becomes plus 24 equals 9. Combine like terms, we have negative 8x plus 25 equals 9. Move all my numbers over, so subtract 25. You get negative 8x equals negative 16. Divide both sides by 8 and get x by negative 8 and get x equals 2. Make sure you keep your negatives where they need to be, and you'll get the right answer here. The next question is asking just to manipulate some numbers. Say we have I over R equals P. We want to solve for R. So we want R as a numerator. So to do that, first we need to get rid of it as the denominator. So multiply both sides by R. These R's cancel. We're left with I equals P times R. Divide both sides by P. R equals I over P. Then we're going to have a square root. Let's say we have 50x to the 15. So neither 50 nor x to the 15 are perfect squares. So we need to find perfect squares that go into them. 25 goes into 52 times, and we're going to subtract 1 from 15 here, so x to the 14, and we still have the x. So now we can take the square root of 25, which is 5, square root of x to the 14, which is x to the 7, and we still have square root of 2x. And the last one that we're going to have, something like square root of 5 times, in parentheses, square root of 10 plus square root of 847. In this situation, we can change the 10 into 5 times 2 to make things easier. And for 847, 5 doesn't go into that, but we need to find a perfect square that does. And the perfect square that will go into that is 121. So I'm going to rewrite this as square root of 5 times 2 plus square root of 121 times 7. And then I'm going to break it up into another step to show a little bit more. I'm going to keep square root of 5. I'm going to change this to be square root of 5, square root of 2 plus. I'm going to take the square root of 121, which is 11. We still have square root of 7. So now I can do square root of 5 times square root of 5 is 5. And we're left with square root of 2. And here we have plus 11. Square root of 5 times square root of 7 is square root of 35. So that's it for part 2. Do everything on here over and over. As well as part 1, and you'll do really well in the final.